All right, now we're going to determine where the function is, these five different possibilities. So either equal, the function f of x is equal to 0. We're going to figure out where the function f of x is greater than 0. F of x is less than 0, greater than or equal to 0, and less than or equal to 0. So I'll show you how to look at this graph and to help determine how to get your result. And we're going to, I didn't mention here, but we're going to put a result in interval notation. I'll explain how to do that. And okay, so let's look at the first example. We want to figure out where f of x is equal to 0. So f of x, realize that f of x is the output. We plug in x, we get f of x out. So realize that y is like our f of x. So we're looking at the output vertically, how high up we are. So we want to figure out vertically, where are we equal to 0? So realize f of x is equal to 0 where it's crossing the x-axis, where vertically it's at 0. So that would just be at the x-axis. So realize at this point right here, this point right here, and this point right here, we are equal to 0. So this is approximately x equals -5. This is approximately, well, this is x equals 0, pretty sure. And this is x equals, and that would be about 3.5, I'd say. Okay, so we would say that f of x is equal to 0 at x equals -5, 0, and 3.5. And it's good that we did this first because that's going to affect our results here. You're going to see -5, 0, and 3.5 come up again. Okay, so let's look into where f of x is greater than 0. And also notice that notice that when I mentioned we're going to be using interval notation, it doesn't really apply to equal. It's mainly when you're dealing with inequalities. Okay, now let's look at f of x is greater than 0. So again, we're talking about the output. Where is the output greater than 0? What we're saying is, where is it above the x-axis? Where is the function above the x-axis? And I'll draw that in green. Okay, let's draw this arrow in green, I guess. Okay, so we'll notice that it's greater than 0 on these portions of the graph. Okay, so let's just imagine that this is going up forever, up to the right, and this is also going down forever, similarly. Okay, so we'll notice that that this is the portion of the function where it is greater than 0. To write this in interval notation, realize that your solution is x. Your solution is x. And realize that for x, we're talking about horizontally, that it is greater than 0 for this interval from -5 to 0. But it doesn't include -5 and 0 because that's where it's equal. We want only greater than. So from -5 to 0, so in our interval notation, we'd write that -5 to 0. And these are all x values. So you could write it like this. X is in -5 to 0, not including, so it's a soft bracket. It's rounded bracket to represent it's not equal to those values. And then we have, and then notice that we have another interval from -3.5 up forever. So horizontally forever. So we would, to connect one interval to another, proper interval notation, we would put a U representing union. We go from 3.5 and then up forever. X value is up forever, so that would be up to infinity, and that's always a soft bracket. Okay, and then let's look at, we'll use a blue color, dark blue. And we're going to look at f of x is less than 0. And less than 0, we'll see, is where it's below the x-axis. The output is below 0. And we'll get this part of the graph. Okay, so this is x is in. And notice that it starts, and we want to go from left to right. It starts at negative infinity. It goes down forever. It's going to the left forever. So negative infinity, and then it goes up to -5, and that's where it stops, because then it starts increasing. So -5, and it doesn't include -5, so it's soft brackets, always on the infinity side. And then union, because we have another interval from 0 to 3.5. It's below the x-axis. And that's from 0 to 3.5. Okay, so at this point, we want to look at greater than or equal to 0 and less than or equal to 0. These are pretty quick, so we've actually drawn all the information we need already for this. So greater than or equal to 0, we essentially look at part B in the solution we got here, and it's the same solution, but we want to include where it's equal. So we would have x is in, now -5 now would be equal if we put a hard bracket like that. -5 up to 0, hard bracket, union, hard bracket, 3.5 up to infinity. And then always infinity has a soft bracket, because you can never reach infinity. You're always going up forever. There's no end result. Okay, less than or equal to 0, just like the answer for C, but we're going to have some hard brackets on those numbers. So x is in what would be negative infinity, soft bracket. -5 includes -5, and then union, and then we would have hard bracket 0 up to 3.5, hard bracket. Okay, so hopefully that makes sense. We're looking at where it is up above or below, depending on what inequality we have, of the x-axis, because we want to know about our output, vertical. And then our solution will be x. What x values will give you those outputs. All right, so let me know if you have any concerns. I'll be more than happy to help.